Hello everybody, welcome back to Happy Little Diodes. It's repair time again. I've got a 48K on the bench, it's a bit banged up and it's in bad shape. So get yourself a cup of tea because this one is a bit of a journey. It's had a bit of a rough time, this machine. The faceplate's a bit banged up, although I don't really mind that. Don't mind the used look. What worries me is this screen. This is the picture that was sent when the customer got in touch about the repair. And let me just say, if you ever see your Specky doing this, unplug it very quickly and do some fault finding before you plug it in again. The reason being, this display is telling me that the lower RAM chips don't have their voltage supplies in order. These RAM chips really don't like that and are likely to die if powered on for too long in this state. This job is just a repair. We're not going to be refurbishing this case, we'll just be getting the board out and repairing it electrically. Here's the serial number if anybody's interested. Has a Made in Portugal sticker on. So let's take it to bits. All screws are present and correct, which is a good sign I guess. Means that the PCB hasn't been left exposed while it's been stored. No keyboard membrane in there, that's okay, the owner's going to sort that out. So what about this PCB? Let's have a look. 10 points if you've spotted anything wrong with it already. There's some fairly major things visible straight away. I'm going to remove it from the case before we go any further, get some close-ups. Again, it's nice to find all the screws are here. It's just one screw holds the PCB down, but quite often they just loose in there on these old eBay repair jobs. Okay, last chance before I give you the answer. Feel free to pause it and see if you can spot it. The major problems reside around the power circuit area, which is round here in the bottom right and the top right of the board. You might notice that C47's missing. That's not actually a problem. This board's been DC-DC modded, as I can see by some solder splodges around here. Weird is the components aren't there. There should be capacitors and diodes around here. Instead we just have this little splodge of solder. So the mod's been done and then taken apart. Also around here we can see some issues. Look at this capacitor. That's looking a bit wonky to me and looks like something's missing too. Another piece of evidence that the mod's been done. R54 in the bottom right is not a resistor, it's a diode, and that's a sure sign that the DC-DC mod's been carried out. I spotted early on that I don't really like is the use of these radial capacitors. I'd rather use axial. Don't really like bending the legs over. It opens you up to shorts and looks a bit messy. So when we recap, we'll certainly be using axial capacitors instead. But before we get on to any of that service stuff, we need to repair the board. So I'm going to dig up a picture of a working issue 4A board that's been DC-DC modded. Thankfully in the video archive I've got shots of pretty much every issue of board, which is common. So here we go. This is one I prepared earlier. Let's compare that with the board we're working on. Yes, C47's missing as we expected, but we have some other components which are missing. Let's mark up this picture. Starting up the top here, I'm still not happy with this capacitor. I'm going to straighten that up. But directly underneath it, in this slot, there should be a capacitor. The board is marked for a diode, but the DC-DC mod replaces that with a capacitor. And finally, down underneath the keyboard socket, we should see a capacitor and two diodes arranged in a kind of star formation, and none of those three can be seen here. First things first, let's straighten up this capacitor. I'm just going to kind of push it in while I heat the joint, and that should make things look a little bit neater. Now we need to fit the missing components, starting with the capacitor. Actually, on closer inspection, there are legs still there from the components that have been removed from this board. I guess it's been used as a donor board. So we'll remove those legs and clear the joints ready for the new part. We also need to clear the joints down here where the BA157 diode sits. Part of the mod is to desolder one leg of that and put a capacitor in between the diode and the board. So we'll clear that joint too. We also need to clear another ground for another BA157 diode, and I tend to use this capacitor slot by the speaker, which is generally empty on most boards. Here's our first replacement capacitor going in. Let's get this board mended. Now we need to start constructing our little star arrangement of a capacitor and 2 diodes. We'll start by replacing this BA157 diode. This is a normal part of the issue for a power circuit. We're only soldering in one side though, the left hand side will be connected to the new capacitor. Here it is, this goes into the left hand joint of the original diode. We'll solder that in and then join the 2 free legs together. If you're interested in the whole modification, including the values of these components and ratings, then check out the video in the description. I talk through this mod in great detail in an earlier video. As I mentioned earlier, there's one more diode. I'm going to pop one leg into this ground on the right hand side of this unused capacitor space. Once again, just soldering one leg to the board as the free leg will join the other diode and capacitor. Alright, here they are. Let's start by bending this capacitor leg over towards the diode and cutting things down to length. We'll make sure both legs get nice and hot so we get a good connection between the 2 legs, and also we need to leave some space for this second diode to join the party too. Once again, just bending it so that it runs alongside the joint we just made, we can get a nice big connection. Okay, that's looking pretty neat. Our board is once again fully populated, so we can get the multimeter out and start doing some tests. As always, the first test we're going to do is to test resistance from ground to the 3 voltage supplies which feed the lower RAM chips. Almost straight away we can see the 12 volt supply has basically no resistance to ground. That's pretty bad, that's really bad, and means I'm definitely not going to be plugging this thing in until we've found the source of this short circuit. Here's a schematic of a power circuit. We can see the 12 volt supply in the top right, that's the digital supply to the RAM. There's also an analog supply on the right which goes off to the LM chip. We can be fairly sure that the problem is with our DRAM supply, although we can do some tests to gain a bit more confidence there. What I'm going to do is measure the resistance from the positive to the negative side of C44 and C45. C44 is on the left hand side of R62, C45 is on the right. So let's see. Let's start with C45. We've got a very small resistance of about 24 ohms. C44, much less. We're actually down at 9 or 10 ohms. So that kind of makes me a bit more convinced that the short is on the DRAM supply side of that resistor R62. I'm going to assume that the analog supply is good, also partially because I've never had a failure over there before with the 12 volt supply. I'm actually going to desolder C44 because I want to start isolating the part of the circuit in which we find the short. Quick check with C44 out of the circuit to make sure we haven't solved it there, which would be nice if it was just one bad capacitor, but that's never happened for me. And yeah, we still have a short circuit. So what do we know? We have a short on the 12 volt supply to the lower RAM chips. We've taken C44 out of the circuit, we know the short isn't there, and where else could the short be in the power circuit? Well, we've got 2 BA157 diodes here that I've just replaced, so I'm very doubtful that's our problem, and the other path to ground goes through 2 resistors, so I doubt both of those have also died at the same time, so I'm going to say the short is not in the power circuit. Let's look further down the line at the lower RAM chips. This is the only other place on the board that we find a 12 volt supply. You can see it down there in the bottom left, and it's a bit of a funny schematic, but basically there's a 12 volt supply to every single chip. Those 12 volt supplies are separated from ground via C5, 6, 7 and 8. So just in the interest of isolating the fault, I'm going to lift one side of each of these capacitors and just check again that we haven't inadvertently solved the issue. A quick test from 12 volts to ground and nope, exactly the same result. Now I'm very convinced that the short is found within the lower RAM chips, either one or multiple chips. So I'm going to start desoldering the 12 volt supply pin on every one of these chips, and by very carefully wiggling these pins around after clearing the solder, we can actually separate each chip from the 12V supply individually without removing them from the board. So now we know that IC13 has an internal short. IC12 is okay. Number 11 is also okay. Number 10 is shorted internally, so there's 2 chips down. Number 9 looks okay. 8 is very low, 300 ohms. I'm going to replace that as well for good measure. And then we've got 7 and 6, which both also look okay. So 3 bad chips. Here we are, we've tracked down our short, it's through these 3 chips. Good job we didn't keep running it, otherwise more chips would have gone down. And because we know that they're dead, I'm just going to cut the legs. If you do decide to do this, make sure that you cut the legs very close to the chip, not close to the PCB, otherwise you risk damaging the pads and the tracks. Lovely, I've removed the 3 legs which were just poking out of those joints, and now I'm going to clear them of solder, ready for some sockets. It's generally good practice if you've had a chip out to put a socket back in, just helps with fault finding in the future. And we must remember to resolder the 12V pins on all the chips that we haven't removed. I also need to try and get these mangled capacitors back in, so I'm going to try and straighten the legs out a bit and pop them back in, resolder them. Also not forgetting to resolder C44, so we lifted one side of that at the start of the investigation. Time to put some shiny new RAM chips in. Alright, we're fully populated again. Let's do a quick check of resistance from our 12V to ground. Yeah, 1.1 kiloohms, 1.2. That's looking a lot healthier than we had previously. Okay, I'm going to plug it in on the bench supply and then unplug it because it didn't work. What happened? Well, it didn't boot and the current draw was about 200 milliamps instead of the roughly 700, 800 that we should have had. I'm going to very quickly check voltages, and our -5 and +12V supplies aren't there, although the 5V supply is. Now I know from experience that TR4 is probably gone. TR4 is really critical in the oscillator system that generates the +12V, so I'm going to go and check that out. It's probably shorted internally. And yes, I got continuity between these legs, so I'll get it out and do that test again. I'm pretty sure it's a transistor. Ah yes, totally kaput. Well, that's alright, I've got a ZTX 651 here that can go in, brand new. This replaces the original ZTX 650. Let's give it another go, shall we? Well, hey, brilliant, it lives. What a result. We can get on with some more standard servicey stuff now, like this DC socket. I wanted to add a bit more solder. I've seen that these often get holes in the solder joints, so a quick top up can't hurt. I need to add a bit more to the TR5 joints too, because I wicked some of that up looking for a short earlier. The composite video mod was already done on this board. We've seen that it's working, but I'm just going to have a quick look inside the modulator case, make sure I'm happy with it, and yeah, it does look neat to me. No point in redoing that. Let's put the lid back on. As always, I'm going to clean the edge connector with this fiberglass pen. You can use a pencil eraser. Once I'm done with the pen, give it a quick brush with a toothbrush and some alcoholic spirit. Now I want to remove the ULA socket and solder it directly to the board. That way we can fit a heatsink on in the 48K rubber key case. This is kinda down to personal preference, but the owner does want it doing. There's our socket removed, it came out quite easily, and we can simply throw that away. Here's our ULA ready to go in. By the way, if you're doing this job, make sure you fully test the ULA before committing to soldering it to the bod. I've found problems with them before that you don't detect in a normal soak test, meaning that I had to desolder the chip again, which is just more risk and slightly soul crushing. And with that job done, all that's left to do is plug it in for some final testing before we send it off. And then unplug it because it didn't work. Oh no. The screen looked pretty bad, pretty garbled, and I'm desperately just cleaning the board here, hoping that there's a solder splash somewhere causing a short, because otherwise I don't know what I could have done. Well, that hasn't solved it. I really don't want to take that chip out again, so I've been looking around for the source of the short, and I found that these two address lines are shorted together. Not quite sure how. Let's take a look at our lower RAM. You can see that A5 is shorted to A0. But remember, just because I'm measuring the short over the RAM chips doesn't mean the short is in or around the RAM chips. These address lines go straight to the ULA, so it could easily be there, and I did just replace that chip, so I'm going to say chances are the ULA is where this short is, although the easiest test I can do right now is to remove these 3 new RAM chips and just test again quickly. But unfortunately no, the short was still present, so I'm gonna have to remove that ULA chip again. Alright, it came out without too much protest, which is good for me. Let's just see if the short is there between these 2 address lines, and yes, it was. Now that's kind of frustrating because it means I did do a good job on that ULA. The short must be elsewhere. So let's have a look at our schematic. The short is between these 2 lines, somewhere along these green lines. You can do a quick test by measuring the resistance between these 2 points on ICs 3 and 4. We should get a resistance of 660 ohms. The ULA is also removed, so we're narrowing down the search. Let's just do this quick resistance test. Yeah, 660 ohms. So we know the short is in or around the RAM chips if it's not just on the board somewhere. So what are we going to do? We're going to desolder those 2 address pins on every single RAM chip and clear the joints so that they're not connected to the board. We can test each chip individually for internal short. So I'm convinced now that another one of these chips must have died. It must have been on its last legs after the power issues that we saw. That, coupled with the fact that it was working before I did the ULA job, means I'm very convinced that one of these chips must be gone. So I've tested every single one by freeing up the pins like I described, and no, none of them had an internal short. In fact, the short was found underneath the socket. I had to remove them all, and it was just here between this pad and the trace above it. I can only think it must have slithered in there somehow during the ULA desocketing. Slightly annoying, kinda hard to find, but we got there in the end. We can now get to work putting everything back together, putting sockets back in, resoldering these address pins that I've desoldered, and getting this ULA back in the board as well. Then we should be up and running, fingers crossed anyway, because it seems to be full of surprises, this board. Okay, let's see. Oh yeah, put the RAM chips back in, then try it. Okay, wow, am I glad to see that working. Just a couple more little jobs to do now. One of these sockets is standing proud, so I'm going to fit that a bit more flush to the board. Also going to do the same for this new switching regulator that's been fitted, because it is standing a little bit proud. To sort this socket out, I'm going to desolder one of its legs and then heat up the other 2 in turn while pushing it flush with my finger. Lovely, that's looking much better. Let's resolder that leg that I desoldered and also do the same thing with the regulator. Once that's done, we're just testing. One of the tests I like to do is to check that DivMMC devices are working, and lo and behold, it's not. Oh dear. Yes, unfortunately, some CPUs have a minor fault, almost an invisible fault, which means these do not boot correctly. They boot straight to the Sinclair text instead of starting their little operating system. We can observe this fault with the scope. If I measure the M1 line on the CPU, it's just stuck at 5 volts. It should be toggling around with the CPU's fetch cycle, and the DivMMC devices rely on this signal. So what do? We remove the CPU, mark it up so I know in future that it doesn't have an M1, and pop in a new one in a nice new socket. And maybe, hopefully, that is the last job we'll need to do. So let's do that measurement again. We're looking at M1 on the new CPU, and look at that, I've just paused it there. It is toggling around between 0 and 5 volts. Lovely, this is definitely going to work now, let's see. Hooray, it is working. Alright, now all I have to do is test it, I think. So let's get it soak testing, and we can finally put this one to bed. Well, we got there in the end. Thank you for watching and sticking with me if you made it this far. Please click like and subscribe if you haven't already, and please share if you enjoyed it.